Good evening, students. Today we shall discuss graphs of trigonometric functions. Let us have a look at the first graph, which is the graph of Sine X. Okay, just observe, this is the graph of Sine X. Here at 0, you can see this is our x-axis and this is the y-axis. This is the graph of Sine X, what we are observing here. At 0, observe, at 0, the value of Sine X is 0. As you know, sine 0 is equal to 0. So, this graph touches x-axis at 0. So, this is the graph of y is equal to Sine X, right? Y is equal to Sine X. So, if I put x is equal to 0, that is sine 0, y is equal to sine 0. Sine 0 value is 0. So, when x is 0, y is also 0. Then look at pi by 2. So, x is equal to pi by 2. At pi by 2, what happens? So, if I put x as pi by 2, I am getting sine pi by 2. Value of sine pi by 2 is equal to 1. So, observe, at pi by 2, the value of sine x, that is equal to 1. Sine pi by 2 is 1. Then you observe, at pi, x equal to pi, if I substitute, the value of y is equal to sine pi. Sine pi is equal to 0. So, at x equal to pi, y is equal to 0. Then, observe this point is 3 pi by 2. At 3 pi by 2, 3 pi by 2 in terms of radians, in terms of degrees it is 270 degree. At 270 degree, what happens? Sine 270 degree is minus 1. So, you can see the graph lies below x-axis. So, at 3 pi by 2, the value of sine x is minus 1. At 2 pi, again it is 0. Okay. And observe one more thing here. From 0 to pi, the graph of sine x lies above x-axis. From pi to 2 pi, the graph of sine x lies below x-axis. From 0 to pi means first quadrant and the second quadrant. 0 to pi by 2 is first quadrant, pi by 2 to pi is the second quadrant. In the first and the second quadrant, sine x is positive. So, the value of y lies above x-axis means it is positive. Because say here, first quadrant both are positive, x and y. Here x is negative, y is positive. Here both are negative, here x is positive, y is negative in the fourth quadrant. So, here y value is negative between pi and 2 pi. Between pi and 2 pi, x value lies between pi and 2 pi means that angle is either in the third quadrant or in the fourth quadrant. When it is in the third quadrant or the fourth quadrant, the value of y, that means the value of sine x is negative. That is the reason why you are observing that the graph lies below x-axis when x varies from pi to 2 pi. Then you observe one more thing. Look at the graph of the function from 0 to 2 pi, and then you look at the graph of the function from 2 pi to 4 pi. Is it one and the same? The graph of the function from 0 to 2 pi is same as the graph of the function from 2 pi to 4 pi, which is same as the graph of the function from minus 2 pi to 0. That is same as the graph of the function from minus 4 pi to minus 2 pi. That is the reason why I said earlier, that is, for any given trigonometric function, for that given angle, if you add 2 pi or if you subtract 2 pi as many times as you wish, then also there will be no change in the value of that trigonometric function. Okay. So, then look at this, the maximum value of sine x. The maximum value of sine x is 1. So, you look at this graph will never go above this line. This is the line, y is equal to 1. So, sine x, its maximum value is 1. The maximum value is attained at pi by 2, then 2 pi plus pi by 2, that means 5 pi by 2, then 9 pi by 2, etc. And here if I consider this is minus 3 pi by 2. At all those points, sine x attains its maximum. The maximum value of sine x is plus 1. Then the minimum value, you observe this graph will never come below this line. Okay, so it will never come below this line. So the minimum value, and that line is nothing but y equal to -1. The minimum value of sine x is -1. Minimum is -1 and maximum is +1. So the range of sine x is the interval, closed interval -1 to 1. Range means what and all the possible values that sine x can take. Sine x can vary from -1 to +1. Whatever the value that you substitute for x, whatever may be the angle, you will always see that sin x value will always lie in between -1 and +1. Its minimum value is -1, maximum value is +1. It takes all the values that are in between -1 and +1. So we say that the range of sin x is closed interval -1 to 1. What is closed interval? What is open interval? Let me briefly explain that. Here, closed interval means the endpoints are also included. Say this is the real line. Here is the point A and B. A is less than B. Then if I take any value, the interval, closed interval means, so if I write x belongs to the closed interval AB, its meaning is x is greater than or equal to A, less than or equal to B. X is greater than or equal to A, less than or equal to B. Then open interval means, its meaning is the points which are in between A and B are included, but A and B, the end points are excluded. Its meaning is x is greater than A but less than B. Then if I write like this, its meaning is this is the interval A, interval AB, closed at A and open at B. Its meaning is x is greater than or equal to A but less than B. Then if I write x belongs to A to B, open at A, closed at B, this implies that x is greater than A but less than or equal to B. X is greater than A but less than or equal to B. Okay, so here sin x will always lie between -1 and 1, including -1 and including +1. So we say that the range of sin x is closed interval -1 to 1. Then the domain of sin x. What do you mean by domain? Domain is the set of all possible values of x for which that function is well defined. For what value of x this is well defined? Sin x is well defined for any real value of x. You substitute any real value. See, here we have started from -4 pi and ended at 4 pi. It doesn't mean that it will end here. You can extend this graph. So it will go in this way for till -infinity, and here it will go in this way till +infinity. So the range of sin x is the domain of sin x is -infinity to +infinity, or we can say the set of all reals. So this is the domain of sin x. See, now I have briefly explained what I mean by domain and range. Later on in another chapter called functions, you will understand in detail about domain and the range of a function. Okay, so this is about the graph of sin x. Now let's have a look at the graph of cos x. Okay, so look at the graph of cos x. Okay, so just observe here at 0. So now I am considering the graph of y is equal to cos x. This is the graph of y is equal to cos x. At 0, the value of y is 1. At pi by 2, the value of y is 0. Because at pi by 2, this graph touches x-axis. When a graph touches x-axis, its y coordinate is 0. So y is equal to 0 at x equal to pi by 2. That means cos pi by 2 is 0, which we already know that cos 90 degree is equal to 0. Then at pi, observe, cos pi, its value is -1. Then at 3 pi by 2, cos 3 pi by 2 is 0, cos 2 pi is 1. Okay. Another thing you observe, from 0 to pi by 2, the graph of cos x lies above x-axis. From 0 to pi by 2, the graph of cos x lies above x-axis. So it is, whenever the graph lies above x-axis, its meaning is that the value is positive, and when it lies below x-axis, its meaning is that the value of that function is negative. When it lies on x-axis, that means it is 0. On x-axis, y is equal to 0. Any point on x-axis, its y coordinate is 0. You know that, right? So from 0 to pi by 2, the graph lies above x-axis, so cos x is positive, which we know that in the first quadrant cos x is positive. Then from pi by 2 to pi and pi to 3 pi by 2, this point is 3 pi by 2. From pi by 2 to pi and pi to 3 pi by 2, the graph of cos x lies below x-axis. That tells us that cos x is negative in the second quadrant and third quadrant, which you have already seen, that cos is positive in first and fourth, and in second and third cos x is negative. Then from, this is 3 pi by 2, from 3 pi by 2 to 2 pi, again the graph goes above x-axis. So there, that means in the fourth quadrant cos x is positive. And then look at this also. Here also the maximum value is plus 1 and minimum value is minus 1. So the range of cos x is also the closed interval minus 1 to 1. Then range of cos x is closed interval minus 1 to 1. The domain of cos x, this graph you can extend this till minus infinity to on this side, and on that side you can extend up to plus infinity. So the domain of cos x is set of all real numbers. In other words, if I ask you where the function is cos x is not defined, cos x is defined everywhere. Therefore, the domain is set of all real numbers. And look at the graph of the function from 0 to 2 pi, and then you observe the graph of the function from 2 pi to 4 pi. You will see that the graph of the function from 0 to 2 pi is same as the graph of the function from 2 pi to 4 pi. And then the graph of the function from minus 4 pi to minus 2 pi is same as the graph of the function from minus 2 pi to 0, then 0 to 2 pi, 2 pi to 4 pi, etc. Therefore, for this particular reason only, we say that for the given function, given trigonometric function, if I, for that angle, if I add 2 pi or add any multiple of 2 pi, add or subtract any multiple of 2 pi, there is no change in the value of that trigonometric function. We also say that cos x, sin x and cos x both are periodic functions with period 2 pi. That means after length of 2 pi units, the graph repeats. So after 0 to 2 pi, again the graph will repeat. Same graph will be there from 0 to 2 pi, 2 pi to 4 pi, 4 pi to 6 pi, 6 pi to 8 pi, and so on. Okay, then now let's go to the next graph, which is the graph of tan x. Tan x. This is the graph of y is equal to tan x. Okay, observe here. At 0, tan 0 is 0. At pi by 4, it is 1. At pi by 2, at 90 degree, what happens to tan x? Tan x is not defined at x equal to 90 degree. In our table, you must have observed, we wrote nd, that means not defined. Tan pi by 2 is not defined. Why not defined? Because I can write tan x as, or tan pi by 2 as sin pi by 2 divided by cos pi by 2, right? Tan x is equal to sin x by cos x. Sin pi by 2 is 1, but cos pi by 2 is 0. 1 by 0, this is not defined. So at pi by 2, tan x is not defined. Therefore, you can see that there is a break in the function at pi by 2. Not only at pi by 2, at 3 pi by 2 also, at minus pi by 2 also, and on this side, which is not visible here, at minus 3 pi by 2, minus 5 pi by 2, minus 7 pi by 2, and on that side at 5 pi by 2, 7 pi by 2, 9 pi by 2, etc. In other words, at all odd multiples of pi by 2, tan x is not defined. So we observe a break, or we observe a gap in the function at all odd multiples of pi by 2. Then from 0 to pi by 2, look at the graph. Graph lies above x-axis. So it is positive tan x is positive when x lies between 0 and pi by 2, which means in the first quadrant tan x is positive. Then from pi by 2 to pi by 2 to pi, graph of tan x lies below x axis, which is negative. So in the second quadrant tan x is negative. From pi to 3 pi by 2, graph lies above x axis. So in the third quadrant tan x is positive. Then from 3 pi by 2 to pi, again there also tan x lies below, the graph of tan x lies below x axis. So we can say that tan x is negative in the fourth quadrant. Okay, then the range here you see it will go in this way till where? Till infinity. Okay, earlier when we had seen the graphs of sin x and cos x, we saw that the graph of sin x will never go above 1 and it will never come below -1. Similarly, the graph of cos x also will not go above +1 and will not come below -1. Whereas tan x, its maximum value, it is tending towards infinity. Maximum value is infinity and minimum values it will go down like this till -infinity. So the range of this function is open interval -infinity to infinity. Okay, so what and all values it can take? Tan x can take any real number. It can take any value from -infinity to +infinity. Okay, then what is the domain of tan x? See, earlier we saw that the domain of sin x and the domain of cos x both are the set of all real numbers. That means sin x and cos x, they are defined everywhere. So we say set of all reals as the domain of sin x and cos x. But when it comes to tan x, we know that it is not defined at some point. Okay, so domain cannot be the set of all real numbers. What I mean by domain? Domain is the set of all points where this function is well defined. Okay, so is it well defined everywhere? The answer is no. You can see the breaks at some point. Which are those points? Pi by 2, 3 pi by 2, 5 pi by 2, minus pi by 2, minus 5 pi by 2, minus 3 pi by 2, etc. That is the set of at all odd multiples of pi by 2, tan x is not defined. Okay, so other than that, other than those points, everywhere else it is defined. So what do? What could be the domain of tan x? What I do is, I'll consider the set of all real numbers. From that set, I will remove all odd multiples of pi by 2. Okay, 2n plus 1 into pi by 2. When I say 2n plus 1 into pi by 2, that means an odd multiple of pi by 2. N is an integer. Put any value for n, any integral value for n. If I take n as 0, I am getting pi by 2. So I am saying r minus pi by 2. That means from the set of all real numbers, you remove pi by 2. Okay. Then if I put n as 1, I am getting 2 plus 1, 3 pi by 2. So at 3 pi by 2 also, function is tan x is not defined. So I am removing 3 pi by 2 also. Put n equal to 2, I am getting 5 pi by 2. Put n equal to 3, I am getting 7 pi by 2. Put n equal to 4, 9 pi by 2. Put n equal to minus 1. If I put n as minus 1, I am getting minus 2 plus 1, that is minus pi by 2. So from the set of all real numbers, I am removing minus pi by 2 also. So I can rewrite it in this way: r minus 3 pi by 2 minus pi by 2, pi by 2, 3 pi by 2, 5 pi by 2, etc. So what we are doing here is, by writing like this, actually I mean this: from the set of all real numbers, I am removing all these values. Okay, so that is the domain of tan x. Okay, so how do we write the domain? We take the set of all real numbers and we will remove all the points where it is not defined. We know that it is not defined whenever x is an odd multiple of pi by 2. So what did I do? From the set of all real numbers, I removed all the odd multiples of pi by 2. Okay, so this is the domain and the range is minus infinity to plus infinity. Okay, and this is the graph of tan x. See, these three graphs are very important. The other three are not all that necessary, but anyway, I will briefly explain the remaining three also. Look at the graph of cot x. Cot 0, it is not defined. Observe, cot 0 here it is going like this and here it is going like this. So, cot 0, there is a break at 0. Cot 0 is not defined. Cot pi by 2 is 0. Again, cot pi is not defined. Why cot 0 is not defined? I will give you the reason also. Cot x, cot x is equal to cos x by sin x. So, cot 0 will be cos 0 divided by sin 0. Cos 0 is 1, sin 0 is 0. 1 by 0, this is not defined. Okay. So, at 0 it is not defined. At 0, at pi, at 2 pi it is not defined, but everywhere else it is defined. Okay. Then look at the graph of the function from 0 to pi by 2. 0 to pi by 2 graph lies above x axis. So, it is positive there. That means in the first quadrant it is positive. Then from pi by 2 to pi, observe that the graph lies below x axis. So, there it is negative. We know in the second quadrant cot x is negative. Then from pi to 3 pi by 2, graph lies above x axis. Pi to 3 pi by 2 means I am talking about the third quadrant. In the third quadrant, cot x is positive. So, it lies above x axis. Then in the fourth quadrant, from 3 pi by 2 to 2 pi, the graph lies below x axis. So, it is negative in the fourth quadrant. Okay. So, here what is the range? As you can observe, so it will go down in this way and it will go up in this way. The range means what and all the values that cot x can take. Cot x can take any value from minus infinity to plus infinity. So, the range is minus infinity to plus infinity. And what is the domain? Domain is where it is not defined, you observe. It is not defined at 0, at pi, at 2 pi, at 3 pi, at minus pi, minus 2 pi, etc. At all multiples of pi, not just odd multiples of pi, any multiple of pi. At all multiples of pi, cot x is not defined. So, the domain of cot x is r minus n pi, n belongs to set. See, here what I am doing here is, from the set of all real numbers, I am excluding the multiples of pi, that is 0, pi, 2 pi, 3 pi, 4 pi. Put n equal to 0, I am getting 0. Put n equal to 1, pi. So, r minus pi, r minus 2 pi, r minus 3 pi, r minus of minus pi, r minus of minus 2 pi, etc. From the set of all real numbers, we are removing all multiples of pi. That will be the domain of cot x. Okay. Next. This is the graph of secant x. Secant x, this being the reciprocal of cos x. So, cos x value lies between minus 1 and 1. So, secant x value will, it's being the reciprocal of that, will not lie in between minus 1 and 1. You just observe, secant 0 is 1, secant pi by 2 not defined, secant pi is minus 1, secant 3 pi by 2 is not defined, secant 2 pi is 1. Okay. So, here where it is not defined, at pi by 2, 3 pi by 2, minus pi by 2, minus 3 pi by 2, etc., you can observe the break in the graph. So, why it is not defined? Because at those points, cos x will be 0. Cos pi by 2 is 0, cos 3 pi by 2 is 0, cos 5 pi by 2, cos 7 pi by 2, etc. At all odd multiples of pi by 2, cos x is 0. So, there secant x, since it being the reciprocal of cos x, you will get say cos secant 0 as 1 by cos 0, cos 0 is 0, so 1 by 0 not defined. Hence, the domain of this function is set of all reals except the odd multiple of pi by 2. Okay. And then the range, observe it will not take any value between minus 1 and 1. Observe that graph does not lie in between minus 1 and 1. Though its minimum value is minus infinity, plus maximum value is plus infinity, but the range is not minus infinity to infinity. So, from the range is set of all reals, except I have to remove this open interval. It will not take any value between minus 1 to 1, or I can rewrite like this also, minus infinity to minus 1, union 1 to infinity. Now, you just remember this, you will understand in detail when we discuss functions. When we discuss another chapter called functions, they will understand it better. Then where it is positive, where it is negative, it's very clear from this. From 0 to pi by 2, graph lies above x-axis, so positive. From pi by 2 to pi also, pi by 2 to 3 pi by 2, graph lies below x-axis, so it is negative. From 3 pi by 2 to 2 pi, graph lies above x-axis, hence it is positive. So we observe that in the first quadrant as well as in the fourth quadrant, graph lies above x-axis, therefore secant x is positive in the first and the fourth, and in the third and second and third it is negative. Okay. After this, let us move to the last one, which is cosecant x. The graph of y is equal to cosecant x. Okay. So this is not defined whenever cosecant x is equal to 1 by sin x, you know. So cosecant x will not be defined whenever sin x is 0. So domain is the set of all real numbers except the points where sin x becomes 0. So what do I do in order to write the domain? I will write R and remove all the points where sin x becomes 0. Sin x becomes 0 at x is equal to 0, at x equal to pi, 2 pi, 3 pi, 4 pi and so on. So I can write like this: R minus n pi, where n belongs to z. Set of all real numbers except the multiples of pi. Okay. And the value, minimum value is minus infinity, maximum value is plus infinity. But again, just like secant x, this also does not take any value between minus 1 and 1. So this is the domain and the range is minus infinity to minus 1 union 1 to infinity. This is the range of cosecant x. Okay. So this is about the graphs of trigonometric functions. Now I will just write a table for you, where I will give you the domain and the range of all these trigonometric functions. That table, as of now you need to remember that table. These graphs, that idea you should have, which will be useful in solving the problems. Direct as such you will not be asked to draw the graph of this function, etc., that they will not ask you. But remembering these graphs and understanding them properly will go a long way in solving problems when it comes to objective questions. When you are preparing yourselves for CET or the JEE mains questions, so having full knowledge about these graphs is very essential. This will be very useful when we solve problems of higher level, okay, which we shall discuss afterwards later on. Okay, so now I will give you the domain and the range of all these trigonometric functions. Okay. You need to write this as a table: function, domain, range. Okay. Sin x, the domain of sin x is the set of all reals. Range is closed interval minus 1 to 1. Then cos x, its domain is R, range is closed interval minus 1 to 1. For tan x, the domain is set of all reals except the odd multiples of pi by 2. The range is minus infinity to plus infinity, which can also be written as R. Okay. Then secant x, for secant x also the domain is set of all reals except the odd multiples of pi by 2. The range is minus infinity to minus 1 union 1 to infinity. Then cosecant x, for this the range is, domain is R minus n pi, in other words R minus the multiples of pi. I have written it as n pi. This is the domain. The range is same as the range of secant x. And finally cot x. The domain of cot x is same as the domain of cosecant x. So set of all points where sin x is not 0. Sin x is 0 whenever x equal to n pi. So what do we do? From the set of all reals we will exclude n pi. then the range is minus infinity to plus infinity. Okay, so you make a list of this table. You need to remember, as of now you just remember this. Later on when we go to the chapter functions, I'll explain again. Okay, thank you. In the next class, we will move to trigonometric equations. Okay, thank you.